Thank you.
Thank you.
So, hi everyone, my name is Bobby. I'm a recruiter with Fast Enterprises. Been with Fast for about 5 years and I'm based out of Colorado.
My name is Kayleen. I have been with Fast, I think, 3 years to the day. I'm in Idaho now, Boise, Idaho. Also, I'm in implementation consultant, my primary role.
And she is.
I graduated from EW. I also forget to talk too much.
Cool, all right. So, has anyone here heard of Fast Enterprises? Cool, well, that is why I'm here, is to give you a little bit more information about who we are and what it is we do and why I'm talking to you all. So Fast, we are a software IT consulting company for government agencies. So we go in and replace these outdated government software systems with one of our core commercial off-the-shelf products. So we currently have a tax system, an unemployment and insurance benefit system, a driver services and vehicle services system, and then a child support engagement system. So has anyone here had to register for their car in Washington? So you all have been affected by Fast software systems. So yeah, a lot of our common clients are going to be the Department of Revenue, Department of Labor, Department of Licensing, and then the fan favorite being the DMV. So maybe not the most exciting work in the world, but things that definitely have to be upgraded and things that are going to constantly be around. So we do work with government agencies, city, state, and federal level. So we're all across the US, and then we do have a few international locations as well. So I love coming to Eastern because Eastern is actually one of the top schools that Fast recruits from. So we have about 40 current alum that work at Eastern, such as Kayleen. So you can kind of see that everyone is spread across the US, and then a couple people international as well. So we do relocate both our interns and our full-time employees. I personally have not relocated with Fast, but Kayleen has, so I'm going to let her kind of talk about her experience with relocation.
Yeah, so I graduated in December of 2020 from Eastern. And then I was relocated to New Hampshire. It was one of the top 3 choices that I had asked for Fast, and they sent me to New Hampshire. I had movers come to my house. They packed up everything. They put everything in their truck, and they drove everything to New Hampshire for me. Fast will also pay for you to fly out there, or if you decide to drive out there like I did from Washington to New Hampshire with my cats, they paid for my hotels, and then they paid for the miles that I drove on my car, the gas, and I think that was it. And they also put you up in a hotel for about 2 weeks while you're looking for a place to stay. I also made the poor decision to drive from New Hampshire to Idaho again. And they reimbursed me for everything, but I got to see the world's largest truck stop in Iowa, so maybe it was worth it.
Yeah, so really the big thing we want to point out is that we know moving can be really scary, it can be really stressful. So we do try to mediate the stresses as much as we can by providing relocation assistance. So for full-time, it's on average every 2 to 3 years. We do hire movers. And then for anyone who's interested in internship, which is what we're primarily looking for at this visit today, we actually provide housing for the duration of the internship, and it's a paid internship. So what makes a good Fastie? That's what we like to refer to ourselves as. So the first thing, being part of a software consulting company, is our communication skills. So, of course, that kind of consulting piece of it, being able to work with clients, then also being able to collaborate with the team. And then something else I always like to point out is how well you're actually able to combine those technical skills and communication to explain things in layman's terms. That's really helpful to have for the job. Second thing is flexibility. So that's definitely in regards to that relocation aspect, being open to see new places, new experiences, move somewhere new, because you don't get to necessarily pick where you go. It definitely worked out for Kayleen where she got to go to New Hampshire, but you are, especially for interns, definitely kind of just assigned a location. Third thing is self-motivated. So we do have a pretty flat structure at Fast in terms of hierarchy. It's not like after you've been there for 2 years, 5 years, you're automatically going to get some title change. But every single project site that was on that map has a project manager, project architect, and a couple different team leads. If those are things that you're interested in, those are things that you're advocating for yourself to your current project manager, and then they'll try to put you in to one of those roles. Then the fourth thing, which I'd say is one of the biggest things I look for as a recruiter, are strong problem-solving skills. So, it's great if you can find a solution quickly and kind of, dust your hands off, be like, all right, I'm done for the day, I'm gonna be done. But what separates people from being really successful is, being able to see a software solution and say, okay, well, this works. Is there anything I can do to make this more efficient? Is there anything I can do to make this more optimized? Is there anything I can do that will, limit to the amount of time that you have to wait at the DMV kind of thing? So what will you do at FAST? So we're in a transitional phase right now with our tech stack. We're moving from Visual Basic.NET over to C# and then use a SQL Server as our database. Don't require any of those coming in. We really just look for a strong foundation in the object-oriented programming language, but it's certainly helpful if you have experience with any of those. Sometimes people see that we're consulting and are like, well, I have no consulting experience, so I'm not qualified for this job. I would not be at a college campus recruiting people if I required any kind of consulting experience. Really, the consulting experience we look for are people that have worked any job. It does not have to be industry related, just anything where you have to work with others, or even group projects where you have that kind of collaborative aspect to whatever it was you were doing. So why FAST? Why is this a great place to work? Why is this something you should consider? First reason is a cliche reason, but it is my favorite, and it really is the people at FAST. So we have a little over 2,200 employees at FAST, and most are in these roles where they're going to these project sites, and they're going places they've never been before. So, everyone on your project site has been in that position at some point at FAST, so we try to build a strong community, not only at work, but outside of work as well, because we know that that can be kind of a scary thing to go somewhere and not know anyone. Second thing are the benefits. When I was in college, I didn't really think about benefits, but it is very important as you're thinking about your college search. So FAST, we have 100% employer paid medical, dental, and vision insurance. That might mean something to some, might not, but what that means for FAST is that you do not have to pay for anything out of pocket for your insurance or for any of your dependents. Additionally, we have 401k matching program, PTO, and one thing that I love to talk about with FAST is every 4 consecutive years you work at FAST, you get something called a FAST pause, which is a 1-month paid time period off in addition to your PTO that you get at FAST. Third thing is we do give you the opportunity to see the world. So is anyone here not from Washington? All right, everyone is from Washington. And so Washington, wonderful place. I love coming to Spokane. I'm from Colorado, very similar kind of vibe here, but for work, I've been to actually over 25 states for FAST. And so every place I go to has kind of different culture, has a different kind of feel, definitely different food. And so for international, we don't send anyone international unless they volunteer, but even different parts of the country definitely offer their own kind of experience. The next thing is the work that we do is very rewarding. So I know actually no one here had really heard of FAST Enterprises before I came in, but some of you raised your hand about, registering for a car. If you've had to, file state taxes at all at any point, that's all going through FAST software system. So while again, not the most exciting work, it is something that is affecting millions and millions of people across the country and internationally. So it's really cool to be part of a company that's doing that. And then finally, we do have a great reputation at FAST. So we've delivered our software systems on time and on budget for 25 years. And a large part of that is because we have an off-the-shelf system. It's pretty functional day one, so we save a lot of time to have to reinvent the wheel each time, and we can show our clients what our system's gonna look like pretty early on in the process. So who here is going to the Fuse Career Fair tomorrow? Who here is hearing about the Fuse Career Fair for the first time? All right, so a similar feedback as to what I've gotten today. So Fuse Career Fair is happening tomorrow at the Convention Center from 2 o'clock to 6 o'clock. So Haley and I will both be there, and I definitely encourage you to come if you're looking for jobs or internships. I encourage you to come even if you're not super interested, but just want to kind of see like companies there, but you're not looking right now, but in the future. If you're not interested in FAST, but you're feeling overwhelmed when you get there, come chat with us. Happy to come talk to you. But if you are interested in FAST, that's going to be the quickest way to kind of chat with us for the recruitment process. But regardless, first step would be to apply online. So again, we're really looking for our interns right now, but still want to chat with anyone that is interested. So check us out online if you're curious. Anyone have any questions for me before I let you all get back to your projects?
You say like spouses and dependents are fully covered by the insurance?
Yeah.
That's pretty cool. Like how often do you,
On average, every 2 to 3 years, so I'd say that's pretty consistent for you, right?
Where are the internships located?
Anywhere within the US. So interns, that's just 12 weeks in the summer. You'd only be placed on one project for the summer. But again, housing is provided as paid for, and you're fine to bring any dependents with you as long as you just let a part of the kid put you in a space that accommodates that.
Why not Texas?
It's honestly how we get projects is a whole beast that our partners handle, and we have a marketing proposal team out of Idaho as well. So how we get those clients is like years and years of a process. Texas, I think, is just isn't on the radar right now, could open up, but as soon as Texas is on the website, that's when I know that Texas might be on the website. Cool. All right, well, thank you so much for letting me chat, and hope to see some of you tomorrow.
Thank you.
Thank you.
Thank you.
Thank you so much.
Yeah, thank you.
Yeah.
Yeah. See you again in the future.
Yes, for sure.
Yeah, Fast hires lots of EWU students, at least historically have done so. So you kind of have an in. There's quite a history of people coming from our program to work for them. So it's, if they weren't on your radar, now they are.
Exhibit A. All right, thank you. Have a good class.
Is this career fair like a CS folks career fair, or is it just a?
I think it's pretty general. I don't recall as much as I probably should about exactly what's happening at that career fair, but whenever there is a career fair, I highly recommend that people just go, see what's around, pop your head in, even if you don't necessarily talk to a bunch of people, just get familiar with what are the names of companies around. And that can help you figure out where you want to apply, who you might want to talk to or reach out to. And if there are people there, this gives you a sense of, if you're not looking right away, you can ask, what are you looking for out of an applicant? And you can use that information to get started on a code portfolio, on your resume. So people there are usually very helpful. You don't have to be immediately looking for a job right now to want to go to something like that.
Yeah,
Very useful.
I went to one when I was like sophomore. They had a lot of super useful information.
Yeah,
Like I wasn't ready to look for a job or an internship, but it helped a lot with like what to be looking for.
depending on how busy they are, they may also be able to do things like give you feedback. If you say something like, I'm looking for this kind of position, what's my in? Or how can I prepare myself for that? They're looking for students who have that level of ambition. Even if you aren't ready right now, they can give you that feedback because they see a potential employee and they're very interested in people who have interest in them. So again, highly, highly recommend. Okay. We are going to be talking about a new design pattern today. I know, super thrilling. Let's see, we were finishing prototype last time, and I kind of had to very quickly give people this last slide. So I at least want to talk about it very briefly before I dive into Observer. And also just give people a sense of what the final couple weeks are going to look like in the class. So right now we have 2 weeks left before finals, which is kind of scary, but that's where we are at the moment. So my goal is we have our project due tonight. I've seen and heard of quite a bit of stress going around about the project. So I just want to give people a little bit of peace of mind about the project. I know that this is immensely challenging. I know that this is probably the hardest thing you've done yet in your CS education. And while that's okay, that's also kind of scary. I am not looking for 100% perfection with these projects. In fact, it is very likely that I will curve them significantly. Put forward your best effort submit tonight the best that you can. And also make note that this has been a longer term project. This has been assigned for quite some time. If you feel like you're right up against the deadline tonight, think a little bit about how much time you gave early on in this project. And I would think that there are probably quite a few of you that at this stage wish you had started earlier. And that just goes to show that I think that I'm not seeing enough engagement in my office hours. I see it in my other class, but I think maybe on average, I've seen the average student a total of about once. And I would think for a project of this size, I would want to see the average student 3 to 4 times, just in terms of checking in with you, seeing where you are, helping you get unstuck from where you are, iterate, do some work, go home, do the best that you can, get stuck, come back. That whole process is very important, and I just don't think that I've quite seen the level of engagement that I would expect out of a project that's this size. That to me probably just means that either people are scared to ask questions, you're putting things off until the last minute and realizing now that it's more work than you anticipated ahead of time. Always err on the side of this project is bigger than I think it is, and that will help to alleviate something like running up against the brick wall of the project. I'll have a little bit of availability after class, but I do have some work to get done this afternoon as well, so I will do my best to answer as many questions as I can. And again, just turn in the best work that you can, and we'll go from there. My goal is to assign the factory stew lab today. That'll be due probably at the end of this week. And my goal is also to assign the next larger project. But the next larger project is going to build off of this project, because rather than completely try to reinvent the wheel, I think there's some additional functionality that we can add to this system that will be able to use the design patterns that we've covered so far as well. So I will get that written up and out to you hopefully by the end of the day today. That puts us, we also have an exam this Friday. I know we have a lot going on. Study guide for the exam is out. Let me know if you have any questions about that. Lots coming down coming at us at the end of the quarter. But we're almost out of time already. Are there any questions or concerns about factory lab once, or that plus the exam happening on Friday? There's a lot happening this week. And then the next project that'll be due either at the end of next week, and it will not be quite the same size as this first project. It'll be a little bit smaller. Again, I know how tough it is, and I will curb it. All right, prototype. We talked about prototype. Let's very briefly reconstruct that. So prototype was our cloning design pattern. It's useful when we want to make copies of objects, but we can start from a bit of a save point or a prototype, something that is partially constructed already. We store that partially constructed object. We clone that partially constructed object and then just fill it out with the ways that it differs. And that allows us to construct objects faster. So the benefits of going through a process like that is we hide the complexity of making new instances from the client, which is very useful. If we're constructing a very difficult object, the actual logic of what goes on is hidden behind our code. The user still just says, make a new one of these, and a new one is passed to them and they don't know any different. Something happened, great. It was efficient, great. They don't need to know the internal details of exactly what happened or how it was constructed. So the user doesn't need to specify anything. It looks the same from their end. It provides the option for the client to generate objects whose type is unknown. That's very useful. If they don't know exactly what the type of their object is, we can put logic in the prototype to do things like search the monster bestiary example that we had to be able to fill out the exact kind of object and go search for it. Copying an object can be significantly more efficient than creating a new one from scratch. When do you want to use the prototype pattern? When we have to create new objects of a bunch of different types in some kind of hierarchy, think things like monsters. A monster is a great example of this because there are so many different base kinds of monsters. Biggest drawback to using prototype is it can be significantly complicated if there are moving parts. Circular references are one such element where A refers to B, refers to C, refers to D, refers to A. So how do we construct something out of this circular reference when we know that there's no exact endpoint? D refers back to A, so how do we figure out that we're done constructing this object at this point? We just add a reference back. So there can be significant complications with the actual process of this, depending on the application. And it's also worth noting that the work that we're going through to design this prototype is only going to be useful if it saves time in the long run or saves efficiency in the long run. So if we're going to be making lots of these objects in the future, it's worth designing a system that's going to make this more efficient. But if we're only going to be calling this prototype twice in the future, it's not worth taking the time to design an entire structure around something that may save us some time later, but cost us a week worth of development time in the meantime. Final questions on prototype? All right, we will add this to the list of design patterns in our back pocket. And we will talk about a new one. All right, we're going to talk about Observer. Observer is one of the very important patterns because it's so different from a lot of the others. We've seen in one sense that a lot of the patterns kind of have similar problems that generate them, and they come about and they solve very slightly different kinds of problems in different ways. But Observer is one that is very easy to just isolate as, wow, this answers a very different kind of problem or solves a very different kind of problem than the other patterns that we've seen so far. So imagine we're going to be interfacing with some weather data object. So this collects data about the weather of some kind, and then the job is to convert this raw data into some kind of user interface or multiple different kinds of user interfaces to display to a user. So maybe someone is accessing it on their phone, someone is accessing it on a browser, someone is accessing it on a big display. This could be something like train departure times, where you have the big display of train departure times in the actual station, and then you have an app that is able to identify the relevant ones to you that you can check on your phone. You can check it on a desktop and get a different view. So kind of swappable different views. And we want to make sure that we can access that data in the same way. This is an abstraction problem because the data is always the same. So from the weather station is actually using sensors to collect the data. We want a similar kind of object to be able to pull that data from the actual weather station into an object that we could use. And then we need some kind of algorithm to convert this data into the associated user interface that we want to share. And there may be very different display devices here. So there's a big dotted line. We don't need to create the weather station. We don't need to worry about how the weather station is collecting its data. We just need to construct the weather data object from the data that's in the weather station. And then we need to worry about how are we going to display this information to a user in a way that is extendable. So as we add new display devices, we don't have to go back and modify the weather data object at all. So the weather data is going to have the associated methods here: get temperature, get humidity, and get pressure. We're also going to have a measurements changed method. The measurements changed is going to update different displays So maybe we have a mobile display, a desktop display, and I don't know, some other kind of display. And that's gonna keep track of the current conditions, the weather stats, the associated forecast. And we need to be able to support lots of different devices. So what we know, weather data class has getters. Measurements changed is called whenever we have new data available, and it's gonna update the value of any of the fields in this object such that the methods that access those fields will access the new values of those fields. So whenever the weather station gathers new data, we need some way to update this. Do we agree that that's kind of a complicated problem? How would we solve a problem like this? How do we know when the weather station has new data available? There are kind of two architectures that might make sense here. Can anyone think of what one of them might look like?
Check. Things there.
You could do that. So we need some way of pulling that data to say, are you changed? How frequently would you do that?
I mean, you could do it whenever like the user is like, reload the page.
So it could be some kind of request. Yeah, so we're going to talk about the concept of a push architecture versus a pull architecture. A push architecture is when you submit the request. It's like, all right, hey, do you have new data for me? And then it responds, yes, I do, or no, I don't. If yes, I do, then it sends the data. But there may be new data for a long period of time before you send that request. So it waits for you to request it. The pull architecture is every so often, it's going to just take data from the weather station. It may be new data, it may not be new data, we don't know, but every 30 seconds, we're just gonna pull the most recent data, check and see if it's different. If it is different, then we go through the algorithm to update the displays. So that's the push versus pull. Do we initialize that? Or are they sending us the data every so frequently? Turns out that this doesn't actually matter for this design pattern, but it's worth knowing for the future that you can implement this in one of two different ways. So we have three different displays. We want to display the current conditions, the weather stats, and the forecast based on this. And we note that our implementation should be expandable because there may be future display elements that we want to modify or completely new display types. If maybe in 5 years, the average phone screen size is 3 inches larger, then maybe we want to change up how our display is handled so we can fit more information on the display screen. Something like that. A user should be able to change how they receive that display at will. So they should be able to do something like, yes, I'm on my phone, but I want the desktop display. I'll turn it sideways and I can deal with the desktop display rather than the mobile display. They should be able to swap that out at will because it contains the same data, the same weather data, right? So it's just a matter of how that data is being communicated to the end user. Go ahead and get together with people who are near you and try to brainstorm a solution to the problem. How would we do something like this? What would the actual UML diagram look like? What classes do we need? What methods do we need? How are we going to solve this? So find at least one other person. It's easy. There are only 6 people in the classroom. It's a little bit harder on Zoom where we have, what, 8 of us? Calvin says sorry.
It's okay, Calvin. Skipping today. Now it's one.
For those of you remote, just try to draw some kind of UML diagram. That would probably be easiest.
There's like a next method in the interface. So they have connected to the next. Instead of yeah. So we on screen. So our data. Then you still use, but data comes from the same class.
What ideas did we come up with?
You can do like a link list kind of thing.
Some kind of list?
Each display is just a node, like an interface with the next and previous method.
Interesting. Would those have associated labels? If the user said, I wanted to subscribe to this particular display, how would you use a list to return them the associated display?
Like to add it to the list?
So they have a feed basically, or a list of displays that they're interested in. They would like to receive in different capacities. If we have a linked list, do we just go from the head on down till we find the associated display? Do they have like some kind of name that you keep track of, and then go down the list, pull the display and associate it with their account somehow?
Yeah.
Makes me think if we did that, we probably want something like a map where we could search by key. Rather than say, is this node the correct display? Is this node the correct display? Is this node the correct display? You have a map to be able to find it easily. Have you talked about maps at all in data structures?
Yeah, which dictionary, so.
Yeah. So let's take a look at a first attempt here. I say first attempt because there are probably going to be some issues with it. So go ahead and analyze this interpretation. So we're going to say that we have, there we go, that's probably big enough. We're going to assign 3 variables equal to the temperature, humidity, and pressure that we grab from the weather data station. Then we want to update the current condition display with that information. And then update, so we have the current conditions display, the statistics display, and the forecast display. We're going to update all 3 of those based off of the data that we get. What issues do we see?
You want to add a new display, you're gonna have to come back to this code, right?
Yes. Yep. And that might be something that's difficult to think of in advance, right? To be able to remember to come back to this if we have an additional display. Any others? That is kind of a big one, right? Yeah. So we call an update like this an area of change. So think about what changes in your classes. It's best to design classes that have a single area of change. It would be nice if we could encapsulate this into the object that's being changed, right? The display is being updated. So we shouldn't be updating a display in a measurements changed method inside of a weather data object. We should be encapsulating this inside of some kind of current condition display class object instead, so that it updates, it calls the associated update, it has the data that it needs. This update should be done elsewhere. And then we have no way to easily add more displays without coming back and editing this code, which is also not ideal. Agreed? So it's the same kind of issues that we've seen before, in that we have code that is way too tightly coupled with other classes and too much change needs to happen. So we want to factor this out into their own classes. So let's try to generate the importance of the observer pattern independent of this idea, and then we'll come back and apply it to this weather data object. But think for a second, I know this is dating myself and this book. Think about how a physical newspaper subscription works in general. First, the publisher goes into business and starts publishing newspapers, starts printing them. You do not get these newspapers delivered to you because you have not subscribed to the newspaper. The newspaper can exist without your being aware of it necessarily. After you become aware of it, you subscribe to it saying, I would like to receive this newspaper every day, every week, however frequently. And then after you subscribe, you begin getting these newspapers as they are published from the publisher, but not the old ones from 10 years ago or even a week ago. You start only getting the new ones after you subscribe. Eventually, you get tired of receiving newspapers you don't read every day, so you unsubscribe. And after that, on an every day or every week basis, you stop getting newspapers. Now think about it from the company's perspective. Every time we publish a paper, we send a copy to every current subscriber. We just look at our current subscriber list, and for each member and the subscriber list, we send them a paper. It's not more complicated than that. The subscriber list may change on a week-to-week basis or a day-to-day basis, but that doesn't matter for the use of our algorithm to send them the associated paper. We just still iterate the current list and send them something. How does this relate to the problem at hand? The weather data.
If they're subscribed to like the certain feed, then they're a part of it and they also get sent the information.
Yes. So we can actually, without modifying the weather station at all, start to basically have a publisher subscriber situation where when we're an object, a current kind of display, and we want to update our display, we can be subscribed to an update system. And that way, whenever an update happens, we get notified of those updates to the temperature and pressure, et cetera, when those change. It becomes kind of like a subscription service. So we have a publisher and we have a subscriber. The publisher produces information and the subscriber is interested in that information as it changes. Whenever you have this particular kind of relationship, when you can identify a publisher and a subscriber, you want to use the observer pattern because it is built for publishers and subscribers. And in fact, the classes are called the publisher and the subscriber because it's modeled off of a newspaper subscription. So how does it work? We have a one-to-many dependency. So the weather station is the one, and all of the subscribers who are interested in the weather data as that changes are the subscribers. So that's the one-to-many dependency between one object and many who are interested in how that object updates. When one object changes, all of its dependents, all of its subscribers are notified and updated automatically. So the publisher class just has a collection of the current subscribers. It just keeps track of, just like the publisher in the newspaper, it keeps track of a list of who is currently interested in updates. It needs a method for a request from another object to be added as a new subscriber to say, hey, I'm interested in subscribing for this. It needs a method for a request to be removed as a current subscriber to say, hey, I'm no longer interested in your updates. Stop sending them to me. And then you need a method to notify every current subscriber whenever there is an associated or interesting change. So that's all that exists in the publisher class. That's all the publisher needs to worry about from the publisher's perspective. The subscriber class, on the other hand, needs some method that gets called whenever the publisher's state changes. So the publisher is going to notify everybody, I've changed. And that tells the subscriber class to pull the new information. So we end up with a system that looks kind of like this. We have a one-to-many relationship. We have an associated subject, object, and then we have lots of observers that are the dependent objects. Questions about this? Does this make sense?
Do the subscribers have to have publisher objects?
Nope.
No.
It's kind of, they need to know what kind of data they're going to get from the publisher. So we need to identify something like, what is going to be passed to me when that happens?
That's
Yeah. So it expects to get that associated information, or maybe it does get some kind of big package object that it then has to dissect to get the important information out of it. You can set that up however you want.
How do they subscribe to it? How do they access the methods that are in the publisher?
They don't need the publisher sends them the associated information. So basically, the only thing you set up from the subscriber's perspective is you send the request of some kind to the publisher, and the publisher is set up to be able to field those requests. And then it adds this object as a subscriber to its list of subscribers. So there is kind of a publisher object, but yeah, you call that particular publisher's method to say, hey, add me to your subscriber list.
Oh, okay.
But since we have that weather data object that's collecting the data for us, we basically say, hey, if I'm a particular kind of display, add me to your list of subscribers so that when new data is available, I can pull it and update my display. And that way we have a bunch of different displays that are all subscribed to the publisher, that is the weather data. Whenever the weather data gets updated, then all of that information is automatically pulled into all of the subscriber classes so that they can each call their update method. It's defined about what information is relevant to that so that it can change and update. I think the UML will make that a little bit clearer as well. So we have subjects and observers. The subject is the same thing as the publisher. The observer is the same thing as the subscriber. So the subject interface just needs to be able to register an observer, register a subject, remove an observer, and notify the observers. And then the concrete subject is going to actually be able to create the logic for that. And note that this means that we can have multiple possible concrete subjects, which means that there may be multiple sources of data or multiple particular kinds of, you get the ability to expand all of those in ways that don't couple that code to your old code. Similarly, we have an observer interface that just says that we need to define an update method. How do you update once you receive information from a subject? And then the concrete observer is actually going to give you the logic of how does this particular concrete observer update based on the information that it receives from the concrete subject. And this allows us to expand both the subjects and the observers into its own hierarchy. We can add or swap observers or subjects on an as-needed basis. Questions on this UML? Does the base concept make sense? We'll come up with a code example here in a moment. If you see or hear the concept of loose coupling, this is what's happening here. We have a loose coupling between our subject and our observer. What do we mean by loose coupling? They interact, but they don't know very much about each other. So the observer doesn't really understand anything about how the subject is collecting its data. It doesn't matter. It doesn't know what kind of sensors there are. It doesn't know how that data collection actually happens. And from the subject's perspective, it doesn't necessarily need to know how many subscribers it has, anything about those subscriber classes, the observer classes, whatever we want to call them. They just know that they're interested in the data, so they send the data to them. It's like the newspaper company doesn't need to know very much about you, the individual. It just needs your payment information to continue the subscription. So a design principle we care about, we want loosely coupled designs between objects that interact with each other. Loosely coupled is much better than tightly coupled. If it's tightly coupled, any change we make to one of the objects means that we have to change something about the other object, which is not good. So some benefits from loose coupling. We don't need to store and communicate excess information that is not relevant to the problem at hand. The only communication is the relevant communication. The only storage is the relevant storage, something that's going to be used. If you're going to pass something like an entire object to another object, and then you're only going to use one of the fields of that object, that's a total waste. We would rather just pass the associated relevant information. An observer is a way to make sure that only the relevant information gets shared between the classes. The subject only has to know the interface the observer uses, not the actual concrete class. So we don't know the observer's concrete class, what it does or anything else about it. We just know that it adheres to that associated interface. And we can use polymorphism to pass that along only the relevant information. Something from this interface. Great, it has an update method. That's all we care about. So that means that we can add new observers at any time, or switch out observers at runtime. In the middle of this, we can subscribe and unsubscribe during runtime. We don't need to know it when we compile our program. That means we can get something like an always online service that is capable of receiving requests to add subscribers or remove subscribers in real time. This means that since it's always running, we can update the observer code as well on the fly. We can change how the observer is handling the information that's being passed to it, and then make that change in real time. Now, instead of using this code, use this code to an online system that doesn't have to go down in the meantime. Have you ever wondered how things like game updates can happen while you're playing it? You need some kind of runtime system like this that makes sure that the changes are just immediately swapped out. You swap out this logic for this logic. But nothing that uses that and is a compile time decision can be affected. All right, let's go back to the weather station real quick. Running out of time, but we'll do what we can. Think about the final UML. What would the final UML look like that adheres to the observer pattern? In fact, I will go back to this UML. So maybe this will bother you in your sleep between today and tomorrow, probably not, given the project that is due tonight. But if you get a chance, think about how the weather data project would make use of this kind of UML, and then what the associated UML would look like for that.
If the subject could have multiple observers, and an observer could have multiple subjects, right?
Mhm.
They're aggregations of each other.
Yeah, kind of, yeah. So you, the human, can have multiple newspaper subscriptions, and a newspaper subscription can send its paper to multiple people.
Is that a line with diamonds on either side?
Yeah. You get a many-to-many relationship of, yeah, you just have to keep track of, you're subscribed to different services, but note that those services are kind of independent of each other. One newspaper doesn't need to know that you're also subscribed to another newspaper. That doesn't affect its business at all.
So you just have a list of subjects.
Yeah,
As you as part of your.
yeah, you might have the same subject or the same observer in two different subject lists because they're subscribed to multiple things. But it allows for real-time online subscription. Any other questions I can answer before we disperse? All right, we will come back to this tomorrow. Do the best you can with the project. I will be in my office for a bit, submit what you can. And do note that I do not expect absolute perfection. Just do the best that you can. Yeah, and expect some kind of factory lab later today.
Sweet.
Remember that there is a study guide up as well. So take a look at the study guide as you start studying for Friday's exam.
How much, I was kind of looking, last night, how many degrees do you have in the master's program?
Some,
Like you have a TA and stuff.
yeah,
And is so it's like, it's only 49 credits, but it says it takes 2 years,
yeah.
because you're not doing.
You have thesis in there as well. And there's lots of thesis credits. So you'll work on it for 2 quarters and it becomes at least half of your workload for those 2 quarters. So that project can be just about anything with any faculty member, really.
Yeah, what, like, I know kind of what a thesis is, but like it's supposed to be like working on something new in the field, kind of, right?
It doesn't necessarily have to be. It can even be a large group project that you want. What I like to be able to do is get some kind of data. So it should be something that is testable or that is, so the one thesis I'm working with right now is a traffic simulator. So we're in Unity.
Oh, for
I know, I think it's in Unreal. In Unreal, we're building a traffic simulation for things like measuring traffic congestion. So we were looking at things like, what does an effective zipper merge look like? If we have 2 different ways of having drivers handle different kinds of merges, what is the cumulative amount of delay that we get? And we can simulate all of that through talking about your thesis.
Engineer.
So you can measure that and you can use that to come up with some real ideas about the actual physical limitations of traffic. And then maybe that it can help form some kind of policy about,
Yeah, we're informed engineering.
yeah,
When, like, how Yes.
I think you just submit the application. I mean, for the thesis.
No, for the master's program.
Yeah, you just submit an application. We actually have we frequently accept the graduates from the programs to the master's program.
To do it like senior year.
Yeah, yeah, usually right as you're about to graduate. As long as you're a fairly solid student, there's no reason.
I think, yeah, my GPA is.
Nice to meet you. Thank you so
Yeah,
much.
we accept worse than that in the program.
It's going up too. 'Cause
Yeah.
The only reason it's 3.6 is because I have a bunch of like C's from when I was like 19.
Yeah, yeah. And we look at things, we look at the entire big picture, it's not just the GPA, like we get the entire transcript. We look at what are the CS courses, what are the non-CS courses? What are the patterns that are associated with what we see? We look for reasons to accept, not reasons to reject.
Yeah, I like that. Have you ever dealt with someone doing an interdisciplinary master's? I saw it.
Not here, I haven't seen it here.
One of our grad students right now is biology.
Yeah,
It says like his undergrad in biology, I think. or chemistry.
Biology and CS.
He's coming to do his master's in CS, but
Oh, cool. Cause I'd like to maybe try to do some like computer or electrical engineering. as
Yeah.
part of it. I don't know.
it's definitely possible.
Yeah. I got a lot.
I don't say, and nowadays with microcontrollers and everything. like-
Yeah,
Like a lot of, like, some of the SKU's projects are like more EE oriented and